it is a really big pain right now to do anything with code you have existing. And I feel like that's a big motivation for what you guys at Sourcegraph do. It's a really big motivation for what we at Akita do. And to me, the legacy code problem was a very big one. The heterogeneity of code was a very big one.
All right, welcome back to another edition of the Sourcegraph podcast. Today I'm here with Beyang, the founder and CEO of Akita Software, the eBPF powered API observability system. Prior to starting Akita, Jean was a professor at CMU where she worked on programming language design. Jean, welcome to the show.
Yeah, thank you. Glad to be here.
Awesome. So to kick things off, how did you get into programming?
Well, both my parents were computer scientists. So they had started out as electrical engineers way back in the day before computer science was a thing. They both got into computers. So we had a terminal in our home pretty early on. I guess like many other parents, they like to teach their kids what they do. So I learned BASIC pretty early. Like I think they taught it to me when I was like 6. We had a computer in our home like pretty early. I taught myself web programming and pretty much like as soon as I got an internet connection, I just got really into the internet. And in fact, I had my internet time limited. And so it felt like a thing, you're not really supposed to do, you're like rebelling. And yeah, so I think that, like programming was a thing that everybody in my family does. But web programming, like that's the thing that you only get to do for a limited time a day.
That's hilarious. What was do you have like an earliest programming memory, like something to do with like BASIC or web programming that stands out?
I was pretty into Visual Basic actually, because I would make these like little visual interfaces to click through, but I didn't really have any, like you couldn't really share it. So that's actually why I got really into web stuff. Because before the web, I was like, all right, I'm making like little VB interfaces, but there's nobody else, like literally nobody else that can run them. So I didn't really understand. I was just like, well, how do people ship this stuff? Like, how's anything work? But I think that like when I started doing web stuff and when I discovered JavaScript, which is funny because I don't do like any front end stuff anymore. But then I was like, whoa, stuff that runs on the internet is amazing. You can just share it with people.
That's awesome. What were some of the things that you built on the web in those early days?
A lot of websites. I had a website about like everything that I cared about. I had a Tamagotchi website. I was really devoted to it. I had websites. I built my friends' websites. I had chat rooms on all my websites. It was very social for me. It was like very much about interconnectedness.
That's awesome. That's awesome. Did you make any friends on the internet?
No, not really. I think most of my internet friends were like pretty like random, creepy people. I think like I didn't really like I mostly just like talk to my existing friends. And I think that, my parents are pretty like warned me off of internet friends pretty early on. So I think that was not something I spent a lot of time doing. Yeah.
Makes sense. Cool. And from there, was it kind of like a pretty much like straight shot to studying computer science in university, or, what led you down that path?
Yeah, that's a great question. Even though, so my mom, my dad, they are both doing computer science and programming. So my mom still works as a professional programmer today. My uncle also, computer scientist. I'm the oldest cousin, but like most of my cousins, like everybody except for one person, works in some kind of
that's incredible
programming or computer science. Or all my cousins in America, I guess.
Yeah.
But but I think that, when I was figuring out what I wanted to do, I think my family was like, well, we immigrated to America so we could have other options. You can do anything. You can be the doctor. You can be a doctor. You can be a lawyer. You could go into politics. You can't be the president, but you can be many other things. And they really wanted me to like explore my options because they're like, we all ended up in this because the government assigned it to us. Maybe you should do something else. Yeah. And then I think there's also like a lot of gendered stuff. I think, at the time, computer science wasn't as mainstream. I think a lot of people saw it as, some of my teachers saw it as like not really like a girl thing, which was, I think, they would really take back today. But at the time, no one knew very much about it. So I declared economics my first year of college. I realized I didn't care at all about the economics classes. Like when it came time to fill out my course syllabus, I just copied it off my friend. I was like, hey, what courses are you taking? I'll just take the same ones.
Cool. Okay, so your kind of like natural proclivities and inclinations kind of led you back to computer science. At what point did you make it official? Was there a point where you're like, this economics?
Yeah, sophomore year. Because I took computer science classes the whole time. I think I was like, man, this economics thing isn't working out. So I was actually pre-med for one semester, and I took like 2 semesters of organic chemistry. And then I was like, this pre-med stuff is like really intense. It's kind of the opposite of what I want to be doing. Also, like taking organic chemistry without taking other chemistries was pretty rough, but like I figured it out by the end. But I was like, man, this is a lot of chemistry.
I feel like everyone's like, oh, that's like a huge leap when you go from,
I was like, I was pretty good at like AP Chem. So I think I can just do it. I remember for like the whole first semester, I just didn't really know. I was like, I don't know. I didn't know what anything was called because it's a lot of nomenclature. And so like, I completely like studied the wrong section of the textbook for like all of the tests. And so then when I came to the final, I like went to the final study session and I was like, hey, I'm like not doing so well in this class. And I was like, oh, I've been studying the wrong section of the book. And then like, I got like, I did really well on the final because I finally studied the right section of the book. And then the TA was like, oh my God, I've never seen someone improve so much. Like you can do anything. Amazing. And I was just like, no, I was really just studying like the wrong section of the book. But yes, it was you. You helped me. Yeah, it was. I think that every teacher likes to believe they like saved someone, and so I feel like she really believes she saved me. But I was really confused because I didn't even I just didn't know what anything was called. So just like let me study the metals section of the book, and I'm like, oh shoot, like the whole test is on the other book section.
That's crazy. Okay, so what I'm getting so far is you come from a family of geniuses and you are yourself a genius.
Well, I think computer science is just a skill. It's like writing or math. It's anyone can do it. Anyone can get better at it. Yeah, I think that when that's your family, that's like, it's just like you start learning it, you learn more of it. Anyone can get better at it. And that's, I think that's a big part of why I believe in accessibility of this stuff. Actually, I think there's no magic about it. There should be less and less magic about this stuff as it becomes more and more a part of our lives.
100%. When you were going through undergrad CS, I mean, having had the background that you did, exposure to computers at an early age, do you feel like your experience was unique in some ways, or how did you view yourself as going through the program?
I think computer science is really different than programming. That's like, and I think that like, if you have been exposed to computers more, it doesn't actually help you in a lot of stuff. It helps you some because you don't have to make the initial leap to like, procedural thinking and like, thinking algorithmically a little bit. But like when I taught at Carnegie Mellon for a couple of years when I was teaching, something that people told me there and that I think is true just across everything I've seen is people who show up having programmed a lot, like still haven't really learned the concepts most of the time. Like, you might have programmed, but like, like how well do you understand algorithms or how well do you understand recursion? And I think that I had a bit of a chip on my shoulder initially, like, I should know this stuff better. I've seen it for a long time. And I think that got in my way. I think that, there's just stuff everyone has to learn initially.
Yeah, 100%.
And I think that like this is really at odds with like I think a lot of people are like, oh, computer science education, like why do that if you've been programming? But I think for me, like learning the concepts was quite a different thing than learning like web programming, for instance.
Yeah, there's something you said for learning, I guess like the principled foundations and the theory behind something, thinking through it in like a kind of like rigorous fashion.
Yeah. Or like thinking algorithmically, or like proving things about what you're programming and like, proving bounds about your algorithms. I think that most people never have to do it again, but it was definitely useful.
Do you think like that appeal, like it was like this new part of computer science, that kind of like transition from like, hacking on stuff and just being like very hands-on on the application side to like diving into the theory, did that lead you into like programming languages? Was that kind of like the motivation or interest there?
Yeah. Because I think for me, one of the main reasons I didn't want to do computer science, or I listened to other people when they were like, oh, you probably don't want to do this, was I thought the tools were just crap. I was like, man, like nothing makes any sense. It works like 80% of the time. I didn't realize that there were like fundamental concepts that this was based on. So I was like, all this stuff is kind of a mess. And so I feel like if I had learned it theory first, I'd just be like, okay, yeah, like, but when I learned the theory after like experiencing the tools for a long time, I was like, what? You mean this can be clean and it was supposed to be like this? And so I think that so it was partly that where I was like, okay, I think it'd be very interesting to spend my career cleaning this up. And I think another part of it was very selfishly motivated, where I loved the theory. I loved my theory of computation class. I thought algorithms was really fun. And so I asked myself, how can I do more of it? Because this does not seem to apply to the kind of hacking I was doing before. So what kind of stuff could I be doing to get closer to doing this kind of work in my everyday life? And so I will say now, as a company founder, I don't really get to do that stuff, but I feel like it's based on those ideas.
When you graduated from undergrad, I feel like maybe a fork in the road for a lot of people is like, do you go and get a graduate degree and do research, or do you go into industry? At that point in your life, was there like a question in your mind, or was it pretty straightforward?
Yeah, definitely. So I had interned at Google the summer before my senior year. So that was summer 2007. Google was very hot then. It was, still like, well, it's still very hard to get a job there, but it was like, like not clear if you're graduating from a top school, if you could get a job there. I had a return offer from there. So my friends were like, oh my gosh, that's where you're going to go. At the same time, I was like, okay, I've kind of done a few internships in industry at this point. I don't know that that's what I want to do, because that's like, I would be using state of the art tools, but I feel like the tools could be better. So where could I work on that? And at the time, there were compilers you could work on. So there was a company called Green Acres in Santa Barbara. They made compilers, I think, like for defense. There were like a few other places working on compilers at the time, but, it was very far from the mainstream. At places like Google, they're working on like the kind of dev tools they were working on was one example of a project they finished the summer I was there was they made distributed linking, so distcc. Because before that, like linking was not distributed, and it took like 10 minutes to link any code. But, I was like, okay, I think you can move the needle on like compilation performance or like performance things, but like anything semantically having to do with programming tools of the kind that I wanted to do, there just really weren't opportunities for doing that in industry at the time. And so to me, the question was, where can you go to get better at doing the kind of work that I wanted to do, which is new kinds of tools, better semantic tools for understanding software systems. And I applied to grad school at the time. I had deferred my Google offer to April or whenever the grad school decisions were. So if anyone tuning in is an undergrad, a lot of undergrads don't know this, but people will make you offers and tell you have to tell them by October. You can defer them until whenever your actual decisions are. And so, at the time I was still like, Google is a very valid option. It depends on what grad schools I get into. My undergrad advisor even said, look, there is a chance you may not get into the schools you want to. Like, it's never a guarantee. You need to be prepared, because I was sort of like, I'll go to grad school if I can get into the schools I want. And it wasn't a very big set. So, I was sort of prepared for all outcomes. But then I ended up getting into some schools I wanted to. I visited them. I really liked MIT. And so that was really the moment when I made the decision.
Yeah, I feel like in up until a couple of years ago, there wasn't really a large like developer tool ecosystem either. Like, the main options, like you said, were those kind of like compiler companies, which
yeah, there's really been a boom in funding in dev tools in the last few years, and I've seen you've written about that. And I think the diversity of dev tools you can work on has also really expanded. But before, even in the bigger companies, so I will say, like, a couple of years after I made the grad school versus not grad school decision, like Google, Microsoft has always had pretty good dev tools actually. But anything that was not Microsoft, Google, Facebook, started investing a lot more in dev tools. And and then like you saw startups joining in that game after that.
Yeah. Yeah. Cool. What did you get up to at MIT?
So during grad school, I created a new programming model and programming language. The language is called Jeeves. The programming model was called policy agnostic programming. The main idea was it factored out information flow and security access checks out of your code. So the general thing I was interested in was like, hey, I'm interested in removing boilerplate from code. At the time, I was still very interested in programming languages are the vehicle, because I was like, okay, code is a mess, and so there's many ways you can go around cleaning up code. And at the time, my undergrad professors were very much believed in the philosophy that better programming models and better programming languages are what it's going to take to clean up the mess of software that was out there. And so the premise is, if only we all use better languages, our lives would be better. And in some sense, that's true. Like, the mainstream has really shifted towards that in the last, 10, 15 years. So at the time I was like, okay, like what's the next thing after memory management that would really clean things up? And so I was like factoring access checks out of code. Like if you write any web program, like half of your code is access checks and everyone gets them wrong. And so something that's been cool to see since then is like there are a bunch of startups now, and there are a bunch of things that are like, let's factor this out as a module, as a library, as like all kinds of stuff. But at the time, I just like really worked on like, okay, semantically, what does it look like to factor this out? If you wanted to do information flow and not just access control. So access control is like, here's a value, let me protect it. Information flow is like, here's a value, let me do computations based on the value. So let's say my location is secret. A like information flow violation would be like, show me all users who are in the Bay Area right now. And if my location is secret, like my location should not contribute to this count. So like, it was really like, let's take this to the next level. How do we track that? And so, I came to some interesting conclusions while working on this, because I was like, okay, cool. This is great as a theoretical model. This is how you would do it. Other people have told me, I've read your thesis, that influenced how I implemented this library. I've been like, great. But for me, I was like, okay, I want to clean up actual code in real life. And so I started implementing a domain specific language based on the thing, based on my language. And I started building web apps based on it, because that's like been my goal of who I want to help, what kind of apps I want to help the whole time. And I discovered something, which is in web apps, most of the code isn't application code. It's application database code. It's your ORM code. You call it to the database. And I said to myself, oh, shoot. Like that was outside of what I was modeling in my application language. And so this is where the illusion broke for me that any kind of language level guarantees really solve all of your problems, because that was when I started realizing just the sheer scale of software heterogeneity. Because even in a simple model view controller web app, you have your model, you have your view, and you have your controller. That's like 3 heterogeneous runtimes. It's 3 heterogeneous languages. There's no way you could have a single one, but that's just so unlikely. And so that was where I started thinking about, oh shoot, anytime you do anything in one of these web systems, you're calling outside of your language. And so if you're coming from we're doing this for the guarantees, like if you have like a completely closed system, like a spaceship or like an operating system or something like that, you can like verify something down to the bare metal. And I think, Amazon does a lot of this like hypervisor, like kernel, like verification stuff. But anything web, like you're just kind of screwed. Like you have so many parts, they're all running in different runtimes. It's worse than running in different languages, because like if you have any kind of like managed runtime, and like any database has a pretty substantial runtime, like you just have so many components, and it's really about like your interacting components is what I realized at that point. And so like to answer the question, what did I get up to in grad school? I made a new programming language. And what did I learn from that? And no programming language is going to save you. There's too many parts.
Interesting. So, I mean, was that like a gradual realization, or was it kind of like a sudden epiphany? Like, do you remember?
There was a sudden realization, but I was also very deep in it, because it was, my first paper was I made this new programming language. And then I went to my advisor 3/4 of the way through, and I was like, hey, like, I figured out this problem. Every time I call it to the database, it actually subverts my guarantees. And he's like, oh, that's great. You have your next paper. And so then, I wrote that next paper, and I think that it was during the process of publishing that next paper that I realized that this was a bigger problem, because I spent something like 3-4 years convincing people that this should be a paper, because there were a few snags. So one was most ways of modeling programming languages only model one. So how do you actually model like a programming model? So you have like lambda calculus, right? But how do you actually model like lambda calculus with a SQL database inside? There were actually like no way, like not really many clean ways that I had seen of doing that before. So like, how do you model that in like the formal programming languages way was like a huge challenge. And then once even we did that, people were like, why would you ever do that? You already have your paper about your language, like you're done. And so I guess I realized a few things from that. But most of the like language modeling community was really not focused on this cross language thing. Cross language is super messy. It took us, like 2 years to really figure out how to get the modeling of the language plus the database right. And I was like, man, there's not that many people thinking about this in a principled way, and everyone is just doing it. And so it was, there was the initial realization, and then where to best do that work was a series of gradual, not even realizations, but trying to do things and getting thwarted in various ways.
So, when you graduated and became a professor, was that kind of thinking top of mind for you? Did that inform sort of like the research direction you picked?
Yeah, absolutely. At the time, I knew that probably at some point I would want to build the kind of tools I wanted to build in industry, because I was hitting these edges of what you could do theoretically in academia. But again, at the time, so I was finishing grad school in 2015. At the time, I would say this was before dev tool startups really took off. The major players were still Microsoft, Facebook, Google, a few other places. And the name of the game in all those places was scale. And so if you had like a small PHP or Python extension that could check all of the code at one of these large companies, you could build it. And everything else had a lot of trouble.
Got it. So seeing that, you kind of went into becoming a professor to see if you could like drive research.
Yeah. So I felt like, the kind of problems I want to work on, academia is still the best place. I will take some time here, work out my ideas. I really didn't think it would happen so quickly that the landscape shifted in startups. Yeah. I think it was really like, I feel like 2013, 2014, you started seeing it, but most of the shift happened post 2015.
Yeah, I can definitely confirm that. Like Sourcegraph got started in 2013. In those days, if you said the words developer tool to any sort of investor, they like pick up their bags and run in the opposite direction.
It was not hot. Yeah.
But yeah, fast forward to now, it's like, one of the hottest areas. And for good reason. I feel like, couple like big inflection points or milestones, I guess, like, the GitHub acquisition by Microsoft. And then you had companies like, GitLab and Datadog come along and just a lot more like companies like that proved out this model of like, hey, like more and more organizations are building software. And guess what? They all care about developer productivity. They all care about tooling. And a lot of these problems are actually like common across organizations.
Yeah, absolutely. And I think that something that's been interesting to see is like, I keep on calling out Microsoft, as Microsoft has been doing this all along.
Yeah.
I feel like also something shifted where that was around the time Microsoft actually started doing less of it.
Yeah.
And so a lot of the Microsoft people went to Google, went to Facebook, and like it started getting spread around.
It's interesting. I think of Microsoft as really the original dev tooling company.
Oh, I mean, absolutely. Yeah.
Like 90s era Microsoft, like, the people always think of like the antitrust, like competing hard with Apple. But I really think that, the reason that Windows won, a big factor of it in the 90s was because they prioritized the developer experience. They had this like wonderful vertical suite of tools.
Yep. Yeah, I completely agree. And they hired a lot of the OG developer tools people. I think, DevDiv at Microsoft still continues to do some of the best developer experience work.
It's kind of interesting too, because I feel like that was maybe the playbook for maybe like tech version 1. Because in those days, you didn't really have like a there was no internet, there was no open ecosystem, and so the way to win was to make your platform the most appealing for third-party developers to build on. That's how you got kind of coverage of all the applications that your customers wanted to do on top of your operating system. And in some ways, like that's still true to a certain extent. You do still have vertically integrated walled garden ecosystems in tech today, and that is a priority to prioritize developer experience for the companies that own those ecosystems. But today we also have like the web and the entire open source ecosystem, and in some sense, like the developer tool startup ecosystem that's popped up in recent years is kind of complementary to that new situation.
Yeah, it's been super interesting to watch. And I think that like no dust has settled yet, which just makes it very fun. Like anyone who tries to say the dust is settling, like it's just not true. Yeah.
We're still early days. It's the Wild West. It's really fun.
Yep. Yeah. And something that's really cool to me is I went into this, and I presume you went into this too, because you saw that developer experience is just so bad.
As you were going into starting as a professor at CMU, was this all top of mind, or did it inform your research area?
The ecosystem changes themselves weren't top of mind. I wasn't like, I want to capitalize on the ecosystem. To me, I was like still trying to get at web programming needs to be easier. It needs to be easier for developers to wrangle the mess of code they get. Everything feels tangled up. How can I make it better? And so to me, the question was always, how can I improve the state of web programming today? And not so much, what's the right time to do this kind of thing. And to me, I thought we were many more years out from me being able to do the kind of work that we're doing at Akita now. I think it helped that I realized that what we should really be doing is working on better tools for telling developers what's going on instead of better tools for helping developers do something new. I think a lot of the work in academic programming languages and a lot of the work in people who make programming languages for fun or work coming out of labs or these design collectives, there are a lot of them are about here's a fun way to write more code. But to me, throughout the whole time, really, I was working on programming tools. The bigger problem is, what do people do with the code they've already written? And that was a big part of why I was really interested in here's how we add a new dimension to code. Like my whole PhD thesis was motivated by, if you've written some code and you want to add some policies to some data, it is hell right now, because you have to go in and thread all of that through. What if you could decouple it? And the overarching theme for that is, if you have some code and you want to do anything different to it, whether it's add a new feature, whether it's make a change that threads throughout, whether it's add instrumentation for some kind of monitoring and observability that you need to thread throughout, it is a really big pain right now to do anything with code you have existing. And I feel like that's a big motivation for what you guys at Sourcegraph do. It's a really big motivation for what we at Akita do. And to me, the legacy code problem was a very big one. The heterogeneity of code was a very big one. And so I was just going after chipping at these problems in ways that I thought were potentially the most medium-term impactful. And what I mean by medium-term impactful, it was not necessarily this is something we can do today. That's the luxury of the fact that I was in academia. And to me also, if you're working on developer experience, 10, 15 years out makes no sense. Like back before, like I feel like in the 70s. It's going to
be a different world then.
Yeah. In the 70s, you could be like, theoretically, developers will exist one day and I can make all these programming models. And it's great because now we've picked up a lot of the ideas from the 70s, but everything that's happening now, it's like what is going to win in the next 5 years determines what are the big problems to work on in the next 10 years. And so to me, a lot of like long-term work in this space didn't make a lot of sense for me for that reason.
Makes sense. At what point was there like a catalyst that made you take the leap from academia into starting a startup? Or was that just a natural progression of your work?
I looked around. I looked at what was happening in the space. I looked at the needs of people. I feel like, as an academic programming languages person, I was on the very practical end of trying to stay in touch with developers. I would do my tour of Silicon Valley companies about once a year and just check things out, figure out what people are up to. And I felt like, there are many more existential questions you have as an academic working on something that's trying to be useful to the, to industry, because you really I pretty regularly ask myself, is this the right thing to be doing? Is this the right place to be doing this thing? And, when I ask myself those questions, I realize the thing I want to be doing is slightly different. And the place to do it is by starting a company. And I wasn't sure at the time. I talked to people at Facebook. I talked to people at Google. I think that if there's certain kind of problems you want to solve, and the places that might let you solve them are dynamically changing every year, it's always good to reevaluate.
Yeah. What was the inception of Akita? Did you have like a working group or a brain trust or like a co-founder that you started out with? What was kind of the...
It was really just me. I trialed a couple of co-founders, and I ultimately decided to take the leap by myself, because the couple of co-founders I tried, they were interested in so initially Akita was much more focused on privacy, because a lot of my work was, programming languages applied to privacy. So I was like, okay, we can start with observability, but for privacy, because that's what my work has been. And so I always had, my intuitive sense was that I wasn't tied to privacy. It was really about certain kinds of programming paradigm shifts. And so the couple of co-founders I initially trialed, they were very tied to privacy and data. And I felt like, okay, like if we pivot out of that, that's not going to go very well. And we ultimately did decide to pivot out of that. And a decision I made up front was like, they're not committed to the same thing as me. Like I was very committed to like, there's a paradigm I want to push through. There's a way of thinking about software I want to push through. And I think that, for someone, if they're like, this is a way to build a business for this kind of data or this kind of privacy, you would just make a different set of choices about what you are and aren't willing to change.
Got it. So you didn't want to restrict yourself to like that specific genre of tooling, I guess.
Right. To me, it was about like, I want people to understand what their software is doing better. Like, whatever insertion we can get a hold of, we take it. And so I think also initially, like, if there had been someone who's like, I agree with you on, programming can be different in this way. And I feel like my founding team eventually was that. But I think initially it was like what I learned from trialing co-founders was like, you have to care about the same thing in the same way.
Can you describe for like people who aren't familiar with it, like what is Akita today? What's kind of the simple introduction?
So Akita is going after drop-in API observability. So our high-level goal is to help developers build more robust and trustworthy software. We believe the way to do it is by making it as easy as possible for developers to understand their running systems. And what this means to us right now is their production systems. I think eventually, like there's a whole space. There's what happens in production, what happens in staging, and then left you shift. But what Akita is today is we are drop-in, we're eBPF based. And so we're completely based on passive traffic observation. And so all you have to do is drop us in, let us passively watch traffic. We don't stand in the flow of traffic at all. Our footprint is basically the additional memory footprint of our passive watching agent. And we tell developers, this is what endpoints you have. This is the usage of the endpoints. This is what they're doing. This is how they're talking to each other. And now you might think like, okay, there's Datadog, there's Grafana, there's all this other stuff. What does Akita do? And we got into this space because people using these other tools even were like, it's so hard. Like we're not really fully using them. It's actually really hard to get this set up. Us to set up APM on our systems, one of our very senior engineers had to spend a week upgrading our libraries. You had to kind of like figure, it wasn't even like clear, like, okay, you have to update this. It was just like broken dependencies for a week. And we had 3 services at the time. This was like before we even wrote a bunch more code. And so so then we were like, okay, yeah. Because I think initially, I had many questions like, where is the highest impact place we could tell developers what's going on with their code? So we started out thinking like maybe people want to know where their data goes. We realized no, like people actually don't. The lawyers do, but a spreadsheet is good enough. And then where we landed is much more basic than what we expected. It's developers don't know what endpoints they have. They don't know how those endpoints are being used. If you have something like CloudWatch, even if you have something like Datadog or Grafana, you have to have a pretty good handle on your system to have instrumented it to set it up in like a per endpoint way. And so like one complaint we see a lot is if someone's using something like CloudWatch, it's like your whole system is down somewhere somehow. What people really want to know is like which endpoint and like how bad is it? And so like the abstraction of an API to us is both like we can reconstruct that by watching traffic alone. We don't have to get in your code. You don't need to instrument anything. And also it's a very useful abstraction because we have users come to us and they're like, look, I only care about 3 of my endpoints, but in order to like properly instrument those 3, like CloudWatch doesn't like, it doesn't make it easier possible to configure that. And like, even if you look at Grafana or Datadog, like endpoint isn't really an abstraction. That's just like, you kind of have to map it all yourself.
Yeah.
And so for us, like we sort of we figured out where our insertion is basically people don't want to do very much work and they want you to get in there and just start telling them things. And so for us, like it's really just been a process of like us getting in there and being like, hey, like we can tell you these things, which ones do you care about? And it turned out, the fancy stuff actually was not what got people. It's like the much more basic stuff. Yeah.
So just to restate that real quick, is the picture that you're after really this kind of like boxes and arrows picture of like each box is like a process or a service that's deployed, and then you show me like the endpoints that one listens on and talks through, and kind of like what other services that each box is communicating with? Is that kind of like the runtime picture that you're after?
Yeah. So, I mean, that's something we started out being able to show. I will say that like what we've gotten requested on is even more zoomed in because people are like, I've got one service and like no clue what it does.
It's like, what is it doing? What ports is it listening on?
So
what sort of
like,
traffic
okay,
does
so
it?
like you really don't know that? And they're like, yeah, because we're like, here's the whole graph. Like this is talking to this here, and people are like, no. Like I have like 3. I really only care about 1, and really of that like 4 endpoints. But like even just like getting my head around that is like hard. And so
it's like here's this creature. I inherited it from someone else who inherited it from someone else. What does it do?
Or I inherited it from myself. It's evolved over time. Or people are using it in ways that I didn't expect. But I said on another podcast I was recently on, like once you ship code, it's legacy because it's out of your control and it's not paged in anymore. And like that's essentially what we found. Like as soon as it hits production, it's like talking to stuff you didn't know. It's behaving in ways that you're like, and so, yeah, for us, we're just like, okay, like, if we said our mission was help people understand like what the heck their production systems are doing and they want this basic stuff, like this is how we fulfill their mission. And like, to me, the vision is eventually there's so much stuff you can build on top of this. So, we've talked about this before, the same way Sourcegraph is like, any question people have about their code, you want to be, I think for us, it's like any question people have about their behavior. We want to be able to give that with as little work as possible to the developer.
Yeah, that's awesome. I feel like one of the key friction points in development is this like translation that has to happen between a static view of the code, which is like what you're thinking about when you're editing source, and the dynamic runtime view of the code. It's like what's actually instantiated, what's actually running.
And that's been super elusive. And so like it's like a mountain we had to climb to figure out our positioning was most of the observability tools out there and the monitoring tools are very ops focused. And so for us, we're like, well, we want to build a very dev focused tool here.
Yeah.
Because developers need to understand what's going on. So I think a lot of the ops focused tools, it's like, well, we're going to let you instrument everything you need to instrument, and we're going to let you know everything. And like, if you're really building a developer focused tool for this space, it's really about like helping developers get their heads around semantics, which like none of the monitoring tools do. And for the observability tools, they're kind of dev focused in like a different way. It's like if you're the dev and you have control over your system, you like take an observability minded mindset from the beginning, then you can get like all of the benefits of a Honeycomb or a Datadog or a Grafana. And for us, we're like, well, like, let's say you're a different kind of dev. You're what I call a 99% developer. You inherit a system. You work 9 to 5. You don't live and breathe tools. Like you don't get your social cred from like knowing about every tool that's on the street. You're not necessarily motivated or able to instrument your code correctly from day one, because it's not day one anymore. And you're like, I get no joy from learning this tool on the weekend. And so what happens to those developers? Because like right now for like other observability tools, like those developers are kind of like the black holes of the landscape. You have like a few like really nicely instrumented services and everything else is just like, okay, that was either inherited or, that team doesn't care about this. And something we've seen is like, you'll have a company, you'll have observability evangelists, and if people are like, yeah, if you like adopt all these like nice things from day one, then you can have all this like, don't you want to be in? And we're just like I've seen this play out with programming languages. And like, I just, if there's like no active reason to put in all this work, people aren't going to. And like as we're waiting for this to happen, more and more legacy code is piling up that wasn't done this way. And inevitably in 1 to 2 years, we're going to find better ways of doing it. So you're always like, the legacy problem is even bigger for like, if you need to instrument your code to understand it. And so for us, like our whole thing is just like, how can we really get in there and just like tell people as much as possible? It doesn't have to be perfect. We're like the phrase we say a lot on our team is B+ on day zero solution. Like it's never going to be your power tool. You're always going to need something better. If that's, if you want full control or anything like that, just like if you wanted to program in something beautiful, like, probably Python is not going to be it, but like, does it get the job done? Is it like the most popular language today? Yeah.
I mean, you got to go with the system that already exists, right? There's no world in which you get to rebuild this, like huge mountain of code from scratch. Yeah.
So like for us, like it's really interesting because a couple of years ago I wrote a blog post that was like, it's called From Balenciaga to Basics, like how we came from like, do you want to know precisely where all your data flows to like, do you want to know where your APIs are? And I feel like every month, like our process has been like more and more basics. We're like, don't you want to know this? It's like, oh, actually, you really want to know this. And that was much more basic. I think that's been really good for us. It's been really eye-opening as well.
Yeah. It's interesting. It's kind of crazy that we don't have something like this already. Like if you were to describe, to maybe like in another engineering profession, like, hey, the state of the world in code is like all our running systems. We basically have very little idea of. And I think that other engineering analogy is something I've really been obsessed with for the last 10, 15 years, because there's a professor, Daniel Jackson. I don't know if you encountered him at MIT, but he was doing a lot of lightweight software verification. So like, how do we prove software systems are correct in like not completely sound ways? So, like similar to Sourcegraph, but it's like if you made like lightweight models of your system and then you like tried to ask questions about them, like, is it true that the system will never fall down in this way and that way? And he gave these incredible talks that talked about engineering analogies. Like, if you're building a bridge, this is like how you would measure it and how you would prevent it from falling down. Or if you were doing, like, if you're building a building, here are building codes. And something that always blew my mind was like, there's not the equivalent for software. And I think, what you all are doing at Sourcegraph is one dimension of it. It's like, well, we're going to like get at software by seeing if you can search for certain patterns. I think that a lot of people in my field use that engineering analogy to be like, well, this is why we have to model every stick and stone that, every instruction. Like the first paper I ever published was called Save to the Last Instruction. And we built this like mini OS kernel that was completely verified. And that was the approach I believed in for a lot of years. But if you think about how engineers do it, they're not like measuring every atom. They're not like modeling every like brick. It's a lot of duct tape.
Yeah, they like put like load on it, and then they're like, does it break? Yes, no. It's very test driven. It's very like, what did we end up with? And like, how do we measure a bridge or how do we measure a building is very much about like, how do we take the artifact that we built and like do stuff to it. And so like, this is why like, I think, what you guys are doing in Sourcegraph, I think things that like help you just like, stress test production systems. So I think, chaos engineering, all that stuff, like that's like, like the first wave of it. I think there's going to be a lot more of this stuff. I think it's going to be much more like stress testing and load testing and like telling people this is what's there, than like, I'm going to test every property. Not to call out certain kinds of testing that I think are cool, but
it's okay. Feel free to be opinionated on this. Opinions are great.
So I think that like I think that a lot of people who are like, we're going to measure software, blah, 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 are like property testing. That's the way. But I'm like, you got to freaking specify every property. So we have people showing up for our beta and they're like, we want to find the properties that property testing missed. And I'm like, that's going to be every property, man. Like, I think like no one wanted to write types. You think they're going to write properties? So I think that, just like as much inference as possible, for basically like load testing and measuring and getting people's heads around production is where the future is.
Awesome.
Not to discount like pre-production. I think like pre-production, you guys have it under control. You're locking it down. I think like the next frontier is like what's going to happen in production.
No, I think that there's like a really nice complementarity.
Yeah. Oh, I completely agree. Yeah. And I saw you had John Kudamal on your podcast. I think that like, playing with like code search plus feature flagging plus telling people what actually happens. Like, I think the future is like that kind of ecosystem, like piping things back from production all the way left and then having control over it. Like, that's really like, I think where the future is. And I think that each piece, like any piece alone isn't everything. Like production without pre-production stuff, like doesn't exist very well because like you can only get so far being like black box on the outside. So I think that like the future is like something that like has a whole loop.
Yeah, I feel like a lot of what you do and what we do and also what Launch Darkly does is really just de-obfuscating what's going on in code and making things accessible.
Yeah. And I think that previously it was like, we're just going to de-obfuscate the next code you're going to write tomorrow. And what I like about all of our stuff is like, no, there's a bunch of stuff that already exists. You need to get your head around it. Here's how.
Yeah. Like the system already exists. We gotta run with the things that we have in production today, that they are that way for a reason, right? Like they've accrued this amount of code because, you get edge cases when your thing is in production that you have to handle. And in some sense, it's almost like so much of the software that we build is actually quite simple to explain in layman's terms, because like the algorithms and the data structures are pretty straightforward, but it's like the translation from that like high level, like English level explanation to like, okay, here's all the source code that wraps around that, or like here's all the like,
here's the source code, here's what it interacts with, here's how it's layered over time. And I think the piece, like the thing I really took away from my PhD was like add any dimension to that code. Imagine adding new permissions to old code. Like you have to touch everything. This plays with like all the semantics. And then I realized, like, imagine adding anything to old code that's a cross-cutting concern. It's the same game. And like, you're going to have all these questions. You can't really get your head around it. But yeah, I think that right now, like code is seen as like what you said, it's like a very static thing, but it's like, we need ways to engage with code that like has been written. So an analogy I really like from, when I was working more in privacy was people would say data is like a corrosive acid. It's just sitting there waiting to explode, or, like it's kind of degrading. And I feel like, code that's been written in the past that you don't have, like you haven't like opened in a while, that's like a bigger corrosive acid because it's not going away. It's like, you can't rip it out. Like data, you can rip it out and maybe you lose some users and they're unhappy, but you rip out old code and your site goes down. And so like, I think that it took people a lot of years to realize data is a corrosive acid. And I think people are finally starting to realize like, code is a bigger corrosive acid, and we just like haven't really been thinking about it that way.
Yeah, I mean, bit rot is real.
Yeah,
and the
yeah. It's not
longer
just,
you go without,
yeah. And it's like you can't just
yeah,
excise the rot. Like you have to live with it. So
no,
what are you gonna
it's
do?
it's a
Yeah.
core dependency. You
Yeah,
can't.
yeah, 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 yeah. Yeah, because I think there's a lot of optimism. Like I think that like software engineering has really shifted to be very far from programming, where like people are like, oh yeah, code is just code. We can always rewrite it, like blah, 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 blah. Like software artifacts are like completely different things. And I think that like only in the last 5 years have I really seen the industry really like think about it as a whole that way. And I feel like we're still very early days in that.
As far as like, the upcoming roadmap for Akita looks, what are some of the exciting like features or things on the horizon that you're really looking forward to?
Yeah, for us, it's I'm doubling down on building for small to medium 99% developers. And so what we found is like, look, this is like, these are the people that we're resonating very well with right now. I think for a while, like all startups play the game, like what size do we really focus on? And I think that like for a while, we're like, okay, we're going to like work on a lot. But then we're like, if we do bigger companies, actually, there's like major other scaling issues because we're like processing API traffic in real time. And so we're doubling down on serving the needs of small to medium 99% developers. And so that means building a lot of the features they've been requesting. So alerts is something. So like right now you can drop us in. You can see metrics and errors. You can see your API endpoints. You can see usage. You can sort by latency P99. And so then people are like, well, we want alerts on top of that. We want other things. And so we're really excited to build that. And the guiding philosophy of our stuff is like as little programmer intervention as possible, because it's, like that's our audience. And so we're like, previously our beta was also not accessible to a lot of people because we were kind of like just like getting real time. Like we got real time in Q2, which like took a while. And then we're like getting real time for more than a handful of users was also like a thing that we did in Q2. And so now we're finally opening up our beta a little more, getting our onboarding more smooth. Like that's what we're shipping this next month. And so we're really excited just to get more users onto our platform, kind of like banging on the rough edges. And so we've been starting to ramp that up more.
Cool. Awesome. If folks are listening to this and want to give it a spin or try it out, where should they go?
So akitasoftware.com. We have a join our beta. We have a join our beta button. Just sign up. I think especially if you join with your work email, you're more likely to get in. Because for us, like the use case we're really going hard after is like IC developer in a small to medium sized company or team. So it's like company without like a ton of DevOps resources. It's a developer who wants observability on their own systems. And so if you sign up with your work email or your real name, even I usually go and like look up the people because our beta still has small enough capacity. I guess I have enough time on our hands that I'm like, okay, we really want to be making sure this is like this is a good match. So yeah, like if you sign up, I'll look you up, and if it looks like your use case might be a good fit, like write to me if I miss you. So there are people who have written to me and they're like, hey, here's my use case, or like I'm working on this for this project. Like here's what it is. Like if anyone with like a use case that sounds like we can help with, and would be a good test for our system, I try to let in. So
awesome. And you're pretty active on Twitter, right?
Yeah, I'm pretty active on Twitter. I don't see everything that comes my way necessarily.
Okay, fair enough. That's not the best channel. Just email you then. Or?
If you tweet at Akita Software, and the Akita Software DMs are actually open. If you tweet at me, I am so active that I don't see everything. But if you tweet at Akita Software, that's the sweet spot, I think.
Okay, cool. Pro tip right there. All right, Gene, thanks so much for taking the time. This was an awesome conversation. Thanks for sharing your journey as a programmer and also telling us more about Akita. It's really cool.
Yeah, thanks so much for having me on. This was super fun. And I think that, like the Sourcegraph part and the Akita part and a few other parts, that's like the next era of dev tools is really facing reality, getting people's heads around code that exists. So I'm really excited about that.
Awesome. As am I.